All right, in today's lesson here, we're going to be taking a look at solving a system of equations here. But in this situation, you'll notice that some of the entries that we've been given here have values of k, and they want us to find the values of k such that the system that you're given is going to result in having a unique solution, infinitely many solutions, and no solution. So these are the goals here. They want you to find the value of k that gives unique solution, infinite solution, or no solution. So to solve a question like this, the way that you do it is you still go through all the same process you would normally go through. You're going to still want to make these entries 0. So right away, I'm going to take row 2 minus twice row 1, row 3 minus 3 times row 1. And doing so, we get the following. The top row I'm not touching, so jot it back down. Second row is going to be 0. This will be k minus 4. This will end up being 4 minus 2k. And the last entry will be 5 minus 6 is negative 1. Continuing up here, this will be 0 here. This next entry will also be 0. And the final entry here will be 7 minus 3k. And then lastly, you'll have 8 minus 9 is negative 1. So you can see here a quick two row operations that we've done on our matrix. Now it's upper triangular. We can go ahead and solve this system. So now the observation here is you want to know when is the system going to be unique, when is it going to be infinite, and when is it going to be no solution. Let's take a look at the option of no solution. Recall, no solution happens when you have an entry. If I have an entry that looks something like this, so you're reducing your matrix. If you end up with a situation like this, that's going to result in no solution because that'll imply, in this case here, maybe your last entry is z. That's going to imply that 0z is equal to some number, let's say 5, and then it's, you can't solve for that. That's going to result in no solution. So that's the idea here. So if you take a look at this last entry right here, if 7 minus 3k is equal to 0, that implies, in this case, that k is 7/3. If k is 7/3, we're going to end up getting a no solution for this system of equations because you're going to end up in a situation like we have here. So right away, we know that under this situation, we have under this situation, we have no solution. Now, the next thing we want to take a look at is, okay, if k is 7/3, we know that we have no solution here. What would happen if this entry were to be 0? So one thing you want to do is you want to examine the options of what makes entry 0 and not 0. So in this case here, if I were to let k equal 4, if you want to examine what's going to happen, if I would let k equal 4 for this matrix here, the top will be 1, 2, 4, 3. The next entry is going to be 0, 0. And then you're going to get 4 minus 8. You're going to get negative 4, negative 1, and 0, 0. And substituting a 4 into here, you'll get negative 5, negative 1. So right away, we're going to have another issue that's going to pop up here. If you take a look, these two entries, if you write them algebraically, is going to be negative 4z is negative 1, and this is negative 5z is negative 1. And these are going to give you different solutions, you can see. Obviously one's going to be a fourth and one's going to be a fifth. So again, we're seeing that, okay, if k equals 7/3, you have no solution. And also, if k equals 4, we also have no solution. Moving along with this question here, if you take a look here, quickly you can see if you let k equal 2 here, this is going to be 0, and these will be different numbers. You're going to end up getting a unique solution. So once you cover sort of the questions that are going to result in no solution in this example, you can go ahead and ask yourself, well, what happens if k is not equal to 4 or 7/3? So if k is not equal to 4 or 7/3, how does that affect the way the matrix looks here? If you take a look at this here, if k is not equal to 4 or 7/3, your matrix will look something like this. You're going to have your numbers here. If k is not equal to 4, this is going to be some sort of a number that's non-zero, right? And then if k is not equal to 7/3, this is also going to be a non-zero entry in this location. And you can see it'll be upper triangular. I can solve for this question back substitution, solve for this one, back substitution, solve for this one, and it's going to result in unique solution for this example here. So therefore we have the option that if k is 4 or 7/3, we are going to have no solution. And we know that if k is not equal to 4 or 7/3, we are going to have unique solution. And lastly, infinite solution does not exist. So we can't have infinite solution with this question. Again, to have infinite solution, you'd have to have a 0 row all the way across, and we can't do that, right? To make this 0, we'd have to let k be 7/3 as discussed, but this will never be 0. So in this example here, you can see that we cannot get one row written as a multiple of the other, so you'll never get a completely 0 row entry here, so you'll never have infinite solution. Right, so we have no solution when k is 4 7/3, unique solution when k is not equal to these values, and lastly, infinite solution does not exist in this example. All right, let's take a look at another example here. So in this example, same idea. Find the value of k that gives you unique solution, infinite solution, or no solution. So same idea. Let's go ahead. I want to make these entries 0. So I'm going to take row 2 minus twice row 1, row 3 minus 3 times row 1. And doing so, again, that top row is untouched. The second entry will be 0. This will be k minus 4. This time this will be 0. This will be 0. The third row, you're going to get 0, 0. And this will end up being k plus 3 minus 9. So you're going to get k minus 6 here for this entry. And then the last one will end up being k plus 1 minus 3. So you're going to get k minus 2 for this entry here. So right away, you can see I've made this upper triangular, these entries. And I want to solve this system. So again, same idea. You want to examine, okay, when is this going to be 0? And will that affect this value here? So right away, we can see that if I let k be 6 here, that last entry is going to be 0, 0, 0, and then 4. And you guys know, as discussed, that's going to create a situation of no solution for that entry right away, because then no solution will exist here. Then you want to move on. Take a look at this entry. Again, if in this situation we have here, if in this situation I have k equaling 4 for the second row, that second row here is going to have an entry of 0, 0, 0, and lastly 0. So as soon as you're solving a system of equations and you're left with a row that is all 0, you automatically are in a situation where you have less equations and variables, and you're going to have yourself infinite solution. So this will end up being here infinite solution. So now we have the situation that, okay, if k is 6, we know we have no solution. If k is 4, we have infinite solution. So then it stands to reason, if k is not equal to 4 or 6, what do we have? So if k is not 4 or 6, and we go to look at our matrix here, you're going to get 1, 2, 3, 1, 0. If k is not 4 or 6, this is a non-zero number. And if k is not equal to 4 or 6, particularly not equal to 6, this is going to be two non-zero numbers. So when you go to solve for this, you're going to end up solving, getting a value, back substitution, solving, back substitution, solving. And the idea here is, in this example, it's going to result in unique solution. So this is another example of find the value of k. If k is 6, no solution. K is 4, infinite solution. Else, we're in a situation where you have a unique solution. Thank you.